In this session, we are going to learn about three ways of training a model. Understanding supervised learning, unsupervised learning, and reinforcement learning is crucial because they form the foundation of machine learning and artificial intelligence, each serving unique purposes. Classification learning is a type of supervised learning where the goal is to categorize input data into predefined classes or categories. The algorithm learns to classify new instances based on the patterns it has learned from labeled training data. Picture this: you are training a machine learning model to identify cats and dogs in photos. It's like being a judge at a paid talent show. But instead of trusting your eyes, you are relying on a tech savvy dog called AI Fido. You show AI Fido thousands of labeled images of cats and dogs, and you are like, okay, Fido, that's a cat. Woof woof, not your kind. And every time AI Fido gets it right, you give him a virtual treat, a bite sized biscuit perhaps. Eventually, AI Fido becomes a pro at tailing Fluffy from Fido. So, next time you are scrolling through your social media feed and see a picture of furry friend, you can count on AI Fido to bark. Cat or a dog? Who knew? Training AI could be as entertaining as pet show. Let's look at regression learning. Regression learning is another type of supervised learning where the algorithm learns to predict continuous values based on input data. In that manner, this is different from classification learning. Think of it like predicting the price of a house based on its size, location, and other features. The algorithm learns from examples where both the input values, like house size, location, and corresponding output, known price, are known. Using this data, the algorithm builds a model that can predict the price of new houses based on their features. Or another case would be a stock price. Imagine Tesla stock price or Nasdaq for that matter. Based on thousands of factors affecting the stock price, if you were to have empirical data of all these factors, the curve over the period for each factor and the stock price, technically, algorithm can learn from historical data and predict the prices of the stock. Regression learning is used in various applications, such as predicting sales revenue, estimating stock prices, forecasting weather, and many more. It's like having a crystal ball that helps you make educated guesses about continuous outcomes based on past data. In earlier session, we looked at supervised learning, classification learning, and regression learning were subtypes of supervised learning. Now let's move to unsupervised learning. Unsupervised learning is like exploring a treasure map without any clues or guidelines. You are on an adventure to discover hidden patterns and structures in your data all by yourself. Think of it like arranging a messy pile of toys into different groups without any labels. Maybe you notice that some toys are blue and others are red, or some are big while others are small. The algorithm does something similar with your data, finding similarities or differences without being told what to look for. Unsupervised learning helps uncover insights and organize information in areas like customer segmentation, anomaly detection, or even understanding the natural structure of your data. It is also used in fraud detection by isolating unexplainable charges on your credit card. It's like having a detective who is great at finding hidden gems, even in the most chaotic situation. Reinforcement learning is like training a pet. It learns by trial and error, receiving feedback from the environment based on its actions. Unlike supervised learning, where algorithm is given labeled examples to learn from, or unsupervised learning, where it discovers the pattern in unlabeled data, reinforcement learning is a bit different. Reinforcement learning interacts with the environment to maximize cumulative reward. Imagine teaching a robot to navigate a maze. In reinforcement learning, the robot starts exploring the maze randomly. When it reaches the goal, it receives the reward. Over time, it learns which actions lead to the highest rewards and adjusts its strategy accordingly. The key difference is that in reinforcement learning, the algorithm learns from feedback received after each action, gradually improving its decision making process. In contrast, supervised learning relies on labeled data to make predictions, while unsupervised learning finds patterns in unlabeled data without specific guidance. In a sense, reinforcement learning is about learning through experience and feedback, while supervised and unsupervised learning focus on learning from labeled or unlabeled data, respectively.